Alright, good night everyone, and welcome back to Miss B Makes It Easier. And we're still on functions, part 1, but now episode 4. Alright, so functions, relations, and graphs. I promised you, and I'm bringing it. So you can show both functions and relations as A, an arrow graph, B, an algebraic rule, C, a set of ordered pairs, and D, a coordinate graph. Here I have what I showed you earlier, where you have the mapping diagrams. You use two ovals. You can use even more than that, but the simple form of it, you represent a mapping diagram using two ovals. And in the first one, the numbers are referred to as elements, and in the second one, the numbers are referred to as images, and the elements are mapped to the images. The elements are found in something called the domain, and the images are found in something called the codomain. The elements, if you are plotting, will be placed on the x-axis, and the images, if you are plotting a graph, will be placed on the y-axis. In the graphs that are functions, a vertical line cannot cross more than one value. The opposite is true for graphs that are not functions. For instance, this graph right here, this one, a vertical line test. So vertical meaning up and down. If you place a line, if you just draw a straight line through the graph, it passes through the plotted line, plotted curve twice. So therefore this is not a function. You see right here? This is not a function. However, if I do a vertical line anywhere along this graph, guess what? It doesn't pass through the line that was plotted more than once. So therefore this is a function. Here's an example. If f of x is equal to 3x minus 1, where x is an element or a member of these numbers 0, 1, 2, 3, 4, A, draw a mapping diagram to represent this. And then B, we're going to produce a graph and then determine if the graph demonstrates a function or not. I'm going to show you how easy this is. You would have done this earlier. So this should just be, what do you call that again? This should just be coming from memory. It should be like an exercise too. So here we're going to draw the domain, the oval for the domain, and the oval for the codomain. And we could write the word domain here, and we could write the word codomain here. And here we see we already have the elements 0, 1, 2, 3, and 4. And now we just need to put the images in here using this number right here. So, using this operation right here. So for this one, it's 3 times 0 minus 1 equal. Then we're going to have 3 times 1 minus 1 equal. 3 times 2 minus 1 equal. 3 times 3 minus 1 equal. And then we're going to have 3 times 4 minus 1 equals. Okay? So this will give us 0. So 0 minus 1 is minus 1. So we put minus 1 right here, and we put the arrow leading up. Let me just put in all my arrows now. 3 times 1 is 3, so 3 minus 1 is 2. 3 times 2 is 6, so 6 minus 1 is 5. 3 times 3 is 9, so 9 minus 1 is 8. And 3 times 4 is 12, and 12 minus 1 is 11. Great. Okay, so you know that these numbers are supposed to be plotted on the y-axis, and therefore these numbers are going to be on the x. So we're going to draw our axis right here. So the x-axis has a shorter number count than the y. X goes from 0 to 4, while y goes from -1 to 11. So we're going to have 0. Wherever it crosses, this says 0. And -1 is underneath here. And then 1 will be here. Don't worry, we're going to learn how to do graphs soon. 3, 4, 5, 6, 7, 8. And I'm going to just rub out these. Okay. 8, 9, 10, 11. Okay, because it ends at 11 there. And then we're going to say 1, 2, 3, 4, because it ends at 4 here. So we're going to plot 0 when x is 0, y is -1. When x is 1, y is 2. So when x is 1 here, remember the x-axis runs horizontally. So just remember the horizon for that. And the y-axis runs vertically. So when x is 1, y is 2. So we're going from 1 and moving up to 2 right here. Put a dot, circle it. When x is 2, y is 5. So we're moving up and moving across. So y is 5 right here. When x is 3, y is 8. So we're moving up and moving across. So basically we're doing like this. We're doing this. Zoop, like a zip. See? Zoop meets dot right there. Get it? When x is 4, y is 11, so we're going up again, and we get a straight line graph. So guess what? If we put any vertical lines here, does it pass the graph twice? No, it doesn't pass, meaning that, does it pass another value within the graph twice? No. No, it does not. Meaning that if you had something like this, it passed the graph twice, passed the line twice. Right? So it doesn't pass the line twice. So at any given point here, you would see a vertical line will pass the graph twice. Here you don't see it passing the graph twice. Understood? I hope so. Now see you around for part 5. Moving on, but actually no. We are basically done with part 1. We're going to be moving into functions part 2, episode 1. See you there.